Thank you. Hi, everybody. So I'll talk about myself later, maybe. Let's get right in. So we're trying to move something to Java 9. We're trying to take an application that works on Java 8 and make it run on Java 9. And let's see what goes wrong. So little public service announcement. This is not about creating modules, unless we're super fast and we have a little bit of time in the end. Otherwise, it's just about taking an application, making it work on Java 9. That also means we're only looking at the dirty underbelly of Java 9. So there are a lot of nice features in there. The module system itself is awesome, but there are couple small language improvements and many API improvements. And they're all worth moving to Java 9. But we're just going to focus on the bad things that might be in your way today. So don't let take away that this is not worth it. It is worth it. You just have to get through some of these things. You can find the slides online. And I'm doing this with a demo application that I created. You can also find it online. And also, I stuffed everything that I could find that could possibly break into one application, so you're not bound to see all of these things. So a little bit, you need to know the platform, the JPMS basics, but I'm still going to go through them very quickly. So this is the unofficial tagline for the platform module system. And the motivation for the module system was that jar hell isn't really it's a thing we got used to, but it would actually be nice to avoid it. So jars don't have names, they don't have dependencies. You cannot create an API that is just visible inside the jar, everywhere inside the jar, but not outside of it. And jars have no concepts of versions. And we kind of got used to this. We have build tools that help us with that. But still, it would be nicer if the JVM would actually see things like we do, which means we give jars names and dependencies and things like that. And some of these consequences are that at runtime you might find no class def found errors, for example, which means some transitive dependency somehow didn't make it into the class path. You have no way to create an API also to have a class that is public just within the jar, which is specifically a problem for maintainers of libraries or frameworks or the JDK themselves. And as I said, you have the trouble of version conflicts. If you have the same two different versions of the same jar on the class path, it's basically draw of luck what happens. Now modules enter the picture. Modules are basically like jars. So actually a module is a representation of a jar at runtime, but it has more information, it has more characteristics. So it has a proper name, and it can define its dependencies. It can say what other modules it uses. You can define an API and can clearly say which of these public classes are actually meant to be supported. It still doesn't have a concept of versions. So this part of jar hell will still stay with us for the foreseeable future. And there are two important goals of the module system. There are lots of other goals as well. We can go to maintainability and security, but the two most important goals are reliable configuration and store encapsulation. And we're going to look at both of these in a minute. So what makes a jar a module? So jar is just, as before, just a container for classes, but in there is a module info.class file, which is compiled from a module info.java file, which could look like this. This is the module descriptor of the Java SQL module. And let's ignore the transitive for now. Basically, it says, I require these other modules. So Java logging and Java XML are also modules from the JDK. It uses something, whatever that means, and then it exports certain packages, meaning these packages, Java SQL, Java SQL, and the last one, these are the public API of the Java SQL module. Now, I talked about two important goals. Reliable configuration is the first. What reliable configuration means is that the module system looks at these requires clauses and makes sure that all the modules that you need are present. And it does that at launch time. So in the beginning, when your application launches, it checks these things. So not later, like after an hour, the application crashes because for the first time you need a class that's not there. It checks at launch time whether all the modules are there. It checks that there are no ambiguities. If you have two jars claiming to be the same module, for example, because they're two different versions of the same module, then you will find out at launch time, and you have the possibility to fix that problem so it doesn't corrupt your application at runtime. Another thing that you can have are static dependency cycles, and then in the end you have no split packages, and what exactly that means we'll look at it later. And the idea is if these sanity checks, if a configuration of jars passes these sanity checks, then it's more reliable and it's more likely to successfully support your application at runtime. The second goal is strong encapsulation, and it builds on these exports directives. So if you want to use the class result set, then before Java 9, so without the module system, it meant that result set had to be public, because it's in a different package. But now there are two more requirements that have to be fulfilled. The first one is it has to be in a package that is actually exported. So if you use some class from a Sun package, for example, that is very, very unlikely that that will be exported by the module owning that package. So you will not be able to use it because the second requirement is not fulfilled. And the third one is you actually have to read that module, which means usually you actually have to require that module. So if I want to use result set, it has to be public, it has to be an exported package, and I have to be written down in my module descriptor that I require Java SQL. And that's the second of the two goals, strong encapsulation. And we'll see how that plays out later when we try to migrate to Java 9. This is just some module graph. It's not even a recent version, so some of these things are not up to date anymore. They are not compact modules anymore. The details don't matter. All I want to show you here is the JDK itself got split into way more than these, actually, about 100 modules. And these have the same relationships that we now have between our modules. So you can see, for example, there should be Java SQL somewhere. Well, let's see. There we go. There's Java SQL. And you can see it depends on XML, as we've seen, and on logging down here. You can see these arrows. So we might have had this idea of how jars or how modules relate to one another before, but now the JVM sees it like we do, so it sees these relations as well. So the JDK got split into modules, and the long-term goal is that our applications run on top of that, also split into modules. But as I said, for now, we're just going to cover how can our application run on, our unmodularized application run on top of this. We're not going to go into any of these, but there are a couple of nice features that the module system has. One of them is services, where you can decouple the relationships between modules. It's actually a Java 6 feature that got moved, that the module system makes more prominent. We looked at two dependencies, at requires clauses and at exports clauses, and you can actually use these, you can make finer grained variants of these. You can just export to a specific module, for example. Again, we're not going to go into that. Then there are open modules and open packages, which are concepts created to handle reflection, because reflection lost its superpowers. The three rules that I told you about, a class must be public and in an exported package, and you must read that module. Reflection also has to fulfill these three requirements, which means you cannot just reflect over internals of another module. With open packages, you can make that possible, for example, to have Hibernate reflect over your modules. Then there are the unnamed automatic modules, and that's actually interesting for the migration we're going to look at today, at least the unnamed module. So these concepts were just created to give you a migration path to the module system. Layers is a concept where you can take one of these graphs, the module graph that I just showed you, and basically layer several graphs on top of each other. That's an interesting thing for containers. Usual applications will not use that unless, for example, you have a plugin architecture where people can, at runtime, add plugin code, their own code into your application. Then layers would be interesting to you. Whenever you create a new class load in your application now, you could maybe create a layer in the future. And then finally, another great thing is JLink. With JLink, you can take those modules that you need for your application and put them into a runtime image, and you create basically a small JDK just for your application. So you have just the modules that you actually need that can support your application instead of, for example, you don't have to have the Java desktop module in there, or the JavaFX WebView module, which has the huge Chromium, which it lugs around. So with JLink, you can create a runtime image for with just the modules that you need. And if your application is already modularized, you can stuff in the application too. So you can ship an entire image with your entire application, where everybody can just go into bin and call your launcher, bin my app, and then it launches with the self-contained JDK. So now let's move from the general description of the module system to something a little more specific to our use case. The basic crux of the module system is that while usually module systems are kind of in or out, you either modularize everything or nothing, that doesn't work for the JPMS, because the JDK is modularized, so it runs in modules, but legacy jars, let's just say just jars, regular jars that work on Java 8 are supposed to work on Java 9 too, so these are not modularized. So how do these two things interact? So the solution to that is the so-called unnamed module. The unnamed module means whatever you put on the class path, the unnamed module wraps all of that. So when you have three jars that are later maybe three modules, then you have module boundaries between them, you have the relationships that I talked about earlier. None of that is true in the unnamed module. The unnamed module just picks up all the classes from the class path, puts it into one module, and then about the three properties, the name doesn't have one. The reason is that you're not supposed to use it to require the unnamed module. Then the second one, which modules could the unnamed module read? Well, it doesn't have a module declaration. It can't really tell what modules it needs, so it can just read all the modules. And likewise, it exports all packages. So the term, the chaos of the class path, I think maybe it was Ellen Bateman, I don't know where I read it first. So the idea is that the chaos of the class path that exists now basically lives on in the unnamed module. So all these crazy things that you do in a class path, like splitting packages between jars and reflecting over internals, all of that still works inside the unnamed module. So you get basically, the idea is that the unnamed module is as backwards compatible as possible, behaves as much as the Java 8 class path as possible. So now let's start with the migration challenges. Let's look at what can go wrong when you want to run on Java 9. And the most important thing to realize is that some of these internal changes, some of the changes that were made due to the module system, and some other changes that were actually overdue and were also made now, can break your application, whether you turn your application to modules or not. So even if you not plan to use modules, this will still affect you if you move to Java 8, move to Java 9 or 10 or 11. Of course, all these things are still true in future releases as well. And we're going to look at a couple of things. But before we do that, I actually want to show you the demo application that I have. Let's first look a little bit at code. So this is the application. It's in IntelliJ. You see here that I have a couple of different submodules. So it gets confusing, right? Maven has modules, and IntelliJ has modules, and now Java has modules. So let's just say modules in general. These are just plain Maven projects without any module descriptors. This is just a plain jar that's being created here. And what this application does is it observes other services. The idea is you have maybe a network of microservices, and then this application observes those services and sees whether they're still alive, and then creates some statistics about that. Of course, it doesn't do anything like that. It just creates random data, but so we can observe something happening. The idea is that this data gets collected into statistics, gets exposed with an endpoint, and it's also stored on the in some persistence backend. So let's build this thing. Takes a moment. I need like a jingle or something that plays while Maven builds. So there we go. Everything was perfect. Now let's launch this. You just have to trust me that this is the correct command. And then things are happening. And over here in this other tab, I actually watch this endpoint every second. I pull the endpoint, and you can slowly see how the data is changing here. So this is like, as I said, the random data. Now the application is done. It runs for 10 seconds. Let's see it again. It just stuff, right? So the takeaway is it works on Java 8. It builds with Maven. You can run it on Java 8, and it does these two things, the REST endpoint and the printing to the command line. And now what we want to do now is we want to move to Java 9. So you can install JDK 9 as your default JDK and run on that. I started with all of this when it was still early access, and I didn't really want to do that. So maybe now is a better time to do that. But just in case, we're going to go through the motions of, let's assume you still have JDK as the default baseline for your project. You still have this as a default JDK on all the developer machines. Let's try to to configure the build in a way that allows you to do this in parallel with Java 8 and Java 9. So one way to do that is to run entire Maven build on Java 9 is to look into this file, Maven RC, and in here you can define Java home for just the Maven, So Maven looks into, when you type Maven something, then Maven looks into this file to see which JDK it will use to launch or which environment variables are set. So let's say to my local Java 9 install, and when I then ask Maven for the version, it not only tells me Maven's version, but also which Java version is running on. So you can see I'm running on 904 now. And now I switched Maven to Java 9. Now if I also want to edit my POM to build against Java 9, I can do that. Here I set the source and target to 8. I can set it to 9 here if I want to, but what we're going to do a couple of times is instead we're going to create profiles. So this is, I didn't use this feature a lot before considering Java 9 or working with Java 9. And now I actually do use it a lot. So the idea with profiles is that you can have specific Maven configurations for specific scenarios. And the specific scenario we're going to pick here is it runs on Java 9. So let's call this, this profile Java 9. And then let's say it can self-activate. So it can, when certain properties are fulfilled, it can self-activate this this profile, so we don't have to do it manually. And one of the activations for this is actually which Java version it runs on. So we can put it in like this, and that means this profile activates itself when it runs on Java 9, and now we can change some things. And what we actually want to change is, we want to change a property. Not like this though. There we go. We want to change the Maven compiler property. Maven compiler, no. And we can set source and target, but we can also set release, which is new in Java 9. So you can set source to 9 and target to 9, and then you also have to find the JDK 9 installed to make sure it builds against the correct API. And from Java 9 on, you can use all of that at once by using the release flag. This is not a Maven feature. The release flag is a feature of the Java compiler, but Maven offers it here. Okay, so now we actually start working on Java 9. So now let's build this thing again. So this is how I migrated a couple of applications. You just switch to Java 9, you build, and then you end up with failures, and then you investigate what's going wrong. And basically what I'm going to do here is I'm going to help you investigate. So the first thing that happens here is we cannot find a symbol, something in package sunmisc. So what could be going on here? Before Java 9, it was kind of a convention which packages not to use. Sun put up, I think, a note in the end of the 90s already that you shouldn't use any Sun packages. And of course, everybody ignored that because it's easy to use them, then nothing's actually stopping you. So now these APIs are actually considered internal. So everything that's in sun.star is internal. Most of what's in com.sun.star is internal. And these things are, in the long term, they're properly encapsulated. In the short term, the decision was made that they're still available at runtime. So applications that were compiled against Java 8 and use these internals would run on Java 9. But if you build on Java 9, then you still run into this. And this is what we just observed. We observed something that was encapsulated at compile time. Actually, we're not there yet. So we saw something is gone. And one of the reasons could be that internal APIs are encapsulated at compile time. Some specific APIs may survive longer. So there were some APIs for which there are no good alternatives in the JDK, and these survive longer, and sunmisc unsafe is among them. But the problem that we run into here is actually a different one, because we're using the base64 encoder from sunmisc, and that one has been deprecated, I don't know, for 2 or 3 releases now. And what we're supposed to use instead is a class in Java util. On the base64 encoder, it's not actually being encapsulated. It's gone. It was removed. So let's go to the class. Which one is it? Utils. Awesome. Great naming. So here I do, this one is the thing you're not supposed to use anymore, the base64 encoder. So in this case, what we use instead is, so I have to, I have my notes here, because of course I don't know this by heart. But by now I do, but I didn't before. So you have Java util base64, get encoder, and then encode to string content, get bytes. There we go, and I learned from experience that you also have to kick out the import. And now we hope that that works. And there's utils passing by. Oops, what are these warnings? So first of all, we then continue with the build and run into the next failure, but first I want to look into these warnings. So what we get here is a warning from the JVM telling us, during the tests, while the tests run, it says an illegal reflective access operation has occurred. Some byte body thing, byte body is used by Mockito. I'm using Mockito, so maybe that's the mistake here. Mockito uses byte body, and byte body reflects over class loader, find loaded class. So class loader is a public class, but find loaded class is not a public method. And byte body uses it by using reflection to make it accessible. As I told you, in Java 9, these things are encapsulated. This is not a public API, find loaded class. It should be encapsulated, but for compatibility reasons, it's still available at runtime, but then you get an ugly warning like this one to make you aware of the problem and take a look at it and try to fix it. So now we have several ways to fix it. I first want to show you what could be maybe your first try, and that's we go into that. Let's first here. Let's first go into utils so we don't have to rebuild all the projects all the time. And then we go into that POM for utils. Oh, sorry. So what happens here is, this is the POM for the subproject, and it uses JUnit Jupyter, so JUnit 5, and it uses Mockito and SRJ. And the problem here is that we use this illegal access. And now it's just a warning, but in the future it could lead to the program failing. And what could you do then? One of the solutions is that you use specific command line flags to tell the JVM to still export this. So most of the rules that the module system puts into place, if you have control over the command line, then you can work around that. The idea is that as a library developer, you cannot hide these nasty things in your code. But as an application developer, if you do that, then you can do that. As a library developer, if you do things that are forbidden, you have to actually inform your users about it, because then they have to put in the command line flags. Okay, let's configure the build here to use one of these command line flags. Let's start by copy-pasting this profile. And then here we don't want to influence properties. We want to configure the build, so only if you run on Java 9, because these command line flags do not exist on Java 8. So if you were to put it into the regular build, that would fail. Then let's configure the Maven Surefire plugin. And then each of these plugins has a different way to configure command line flags. This one uses arcline. And now here we can put in the different command line flags to pass to so the Surefire provider passes these on to the JVM that runs the tests. So the first thing we can do, we can use the command line flag illegal access and say deny. What that does is it switches the behavior from give me a warning to don't allow access. So my recommendation is actually to turn on illegal access deny in the build, and then so to be sure that you actually see these, because otherwise warnings can get by in a huge build. If the build fails when you do something you're not supposed to. So now the module system does not allow the access with a warning. It fails with an exception, with this one. And then Mockito builds a whole lot of things around that to help you debug this thing. But the basic point is still here, inaccessible object, inaccessible object exception, unable to make protected final, blah, find load. Accessible, the module Java base, which is the module owning the class loader, does not open Java lang, does not open this package to the unnamed module. Remember, our code runs in the unnamed module, and the module owning the package does not open that package up for reflection, but we can do that on the command line. We can add an opens, and then you say the module Java base, more precisely the package Java lang, should be opened to, and we're now going to put in all unnamed, which means to all modules. So now effectively this package is open to reflection, and we'll no longer see a warning, and everything works fine. And this is a way how you can work around these problems if the libraries or frameworks you use reflect over internals, which they're not supposed to anymore. But a better solution that you should look into first is to not actually allow things that are not supposed to work, but instead look at updates to updating your dependencies. Because that's actually the better solution here. I had to pick a specific version of Mockito that still does this, but is still kind of current, because Mockito uses ByteBuddy, and Raphael Winterhalter, who maintains ByteBuddy, is very cutting edge. So for a long time now already, ByteBuddy no longer does this. You can use any recent version of Mockito which uses a recent version of ByteBuddy, and you don't have to add anything to your build. And this is true for many dependencies, particularly if they're well maintained. There will likely be Java 9 compatible versions out there. So what you should do, instead of trying to get the module system to do the things it's fighting against, instead of fighting against the module system, have a look whether you can update your dependencies to versions that will just work on Java 9. That's also one of the important tips I usually give people. If you want to prepare for Java 9, the best thing you can do is just update all the things. Update your dependencies, your build tool, your IDE. And once you're done with that, chances are you already sidestepped a lot of problems without even realizing it. So if you're thinking about migrating to Java 9, that would be a perfect preparation. Start updating dependencies. OK, so utils builds. Next problem. I should maybe just resume from. So we fail in the REST package, and it tells us that some package javax XML bind is not visible. OK. Why not? So how can you find out, for example, to which module javax XML bind belongs? The Java doc that was updated for Java 9, first of all, has a search field up here, which is just plain awesome. Like it's the simple things. And then you can see the package list here, and you already see that there's that this thing in front, that's the module, because all the information were extended to contain the module it belongs to. So all the packages now list the module. All the classes, if you would click on a class, you would also see which module it belongs to. So Java 9 Javadoc is there for you to help you out with figuring out which modules things belong to. And you also get a small module graph here, which shows the dependencies. Here, you can see what Java XML bind depends on. And now that we're here, we also see it's deprecated for removal. So that might actually be the reason why it's not visible here, because all the other Java stuff is visible. Why would this one not be visible? And the reason is that Java SE actually contains a couple of things that are originally Java EE APIs. I don't know the history why they're there, but Oracle wants to get rid of them, which I think is a good idea to conceptually separate these two. So the Java EE APIs are phased out of Java, and these modules, there are 6 modules that contain Java EE APIs. They are these 6 modules, and on Java 9, they're not resolved by default. That means unless they're specifically required, you won't see them at runtime. And because we're not building modules yet, we have a little bit of trouble of explicitly requiring them. And in Java 11, so the first long-term support release comes out this September, these modules are already gone. So you have to find a different way to using them. The best solution is to use third-party dependencies, third-party implementations instead. But I'm not going to do that here. What I'm going to do here is, once again, massage the module system by using the command line. We're going to see that in a minute. You can see this if you use jdeps. jdeps is a nice command line tool that comes with since Java 8, has been updated in Java 9. You can use jdeps to analyze static dependencies between classes. And I use it here on just some random application. And then you get output like this one. And this shows, for example, this jar depends on these modules. So you can use jdeps to figure out which modules you depend. And you can use jdeps for a lot of things. You should definitely look into that tool. So what can you do? You can pick a third-party implementation. And I put up a question on Stack Overflow and wrote an answer that collects at least one implementation for each of these modules. Or on Java 9 and 10, you can add them as a command line flag. So let's do that for now. Let's have a look first at the message again. There are different things that are complaining here. Let's look at statistics entity. And up here on the imports, we'll see that these were the problematic ones. So what we can do now is we can go to its POM, and then do the same thing again. I'm going to spare you all the details. I'm going to try to copy-paste this from somewhere else. Yes, awesome. But not the Surefire plugin, but the compiler plugin. So I copy-pasted all this profile stuff and put it into the into the Maven module that builds the jar that that uses the Java E API. So now I told you each one does this differently. Each plugin uses the command line differently. This one is, yes, compiler args, of course. And then you go with individual arg tags. Okay, so now we can add a module, add modules, and we looked at name up. It's Java dot, that's a different as annotation, like that. Oh. Let's just build only that single module, and now we changed the error messaging. So now, actually we didn't have this message before. Now it cannot find a class, a symbol that's in some specific package. And that might be weird because if we look this up, it's non-null. That's where does non-null come from? Non-null comes from, see, it's a JavaX annotation package, indeed. But it's not a JDK class. It comes from the JSR jar. But this is a dependency. Why wouldn't the dependency? So why would during compile time, why would a dependency that we have that we declared in Maven, why would it not be there? That's weird, right? We did not make it into the class path, and we can have a look at the class path, and now you kind of have to trust me. Maybe I find it quickly, but it's unlikely that I do. But it's in here. So it actually is on the class path. So that's, oh, there we go, actually. See? There we go. So the jar is on the class path, and still, apparently, the class is not available for the compiler. What is going on here? And it's actually that's the most complicated problem that the Java module system might throw at you. And it's not that common. Actually, I think the JSR annotations are by far the easiest, not by far the most common way to come up to run into this problem. And this is the problem of the split packages that I talked about, that I mentioned earlier. The idea of the module system is each package should have a unique origin. So you cannot have two modules containing the same package. That makes sense from a conceptual point of view, but it also leads to improvements in class loading performance, because now the module system knows for each class in which package it is, and knows for each package in which module it is, so it goes directly to that jar to load a class instead of scanning the full class path all the time. So packages should have a unique origin. And that means no module must read the same package from two different modules. But at runtime, that usually means, or at compile time, that no two modules can contain the same package. And it doesn't matter whether it's exported or not. And the module system checks that. At compile time or at launch time, when you have two named modules and each of them contains the same package, you get a nice mistake. So like, look, you have this package twice. Don't do that. The tricky problem here is the unnamed module is not exposed to these checks. Because remember, the chaos of the class path can live on. We're not going to look into that mess. It just does what it does. So if you have a split package between a named module, in this case it's a JDK module which owns the JavaX annotation package, and a jar on the class path, then the class path portion is invisible. Because whenever the class loader says, oh, I load something from JavaX annotation, I know it's in this module. It looks into that module and then says load non-null, but non-null is not in here. And it doesn't check on the class path. That's why this is a more complicated problem. Some of the examples are JSR 305 is down there, and then you see the XML APIs, and JBoss modules also have this problem. And the reason for that is, so these are just examples, others do too, and the reason for that is that these are actually mostly the Java EE APIs that are split across different implementations. And if you run jdeps, you will actually get, this will actually be mentioned. So if you use this command, as I'm not going into jdeps in detail, you can try this at home. You get a message like this one, split package, JAWAX annotation, and it says, this is the one module that I found, and JRT means it's within the JDK, and this is the module that we just added, and then this is the other jar that makes the problem. So that's interesting. So we didn't have this problem before. Non-null was fine. Then we added this module because we needed it because of another dependence. So because we used stuff from that module, and the moment we added that module to the compilation, then suddenly the non-null annotation went missing. So that's why I'd say this is the most complicated problem that you're gonna face. And then the question remains, what can you do about it? If it's your artifacts, then that's good, because then you can just get rid of this. You can rename the packages, or you can merge the packages, or merge the artifacts. There are several solutions. If you don't own the artifacts, then you you have two cases. Either you have a jar that's actually meant to replace the entire module, then you can do that, or not. And then in the last situation, and that's basically the worst situation, because it means this is a split that you have no control over, and you just have to get to work somehow. And the patch module flag lets you do that, but as you will see when we use it, it's not the nicest flag to use. So what patch module does is you tell the launching module system, look, you have this module there, right? And now look into that jar, and take all the classes out of that jar and stuff them into that module, and act as if they came from that module. So by that you meant the package split, right? Because then the jar doesn't have its own classes anymore, they're all in here. So that part works fine, but that can have consequences. For example, if that jar had a bunch of dependencies, then now that module has to see all of these dependencies, and if that jar, or if that was a module and exported things, then now you have to export these things from those modules. So that's actually quite a complicated thing that it should be definitely your last resort. In this specific case, I think it's the only resort, but also in this case it's not that complicated, fortunately. But it's not trivial to do this in a way that is somewhat stable across builds. I'm actually not sure whether I succeeded in doing that. We'll find out. We go to rest here. Oh, we don't need that. Don't need that either. So we're still here. Now we add another command line flag. And we go patch modules. And so patch a module. And the one you want to patch is this one. And we want to put in, well, the content of the JSR 305 jar. But we need a path, right? We need a path that works. And the only one that I could find, which I think is actually a bad solution to use, and I'm not going to type it out, I'm just going to copy-paste it, is this. So I use the Maven variable for the log repository, and then I know the repository structure, so I go to com, Google, code, find bugs, blah, until I end up with this jar. If you have a better solution, I'm happy to see it, because I'm very aware this is a horrible one. But it works. Almost. What did I do wrong? Not again, like this, when this goes wrong, it always takes ages to find the mistake. Invalid flag. Sorry? New lines, that's true. Exactly, there are new lines in here. Because I copy-pasted it out of the PDF. Where is the new line? I think maybe here. Oh, see, there's even space in there. That's evil. Oh, nice. So remember that I told you about that nice release flag? You can't use it when you patch modules. I'm sure there's a reason for that. But at this point, I just gave up and was like, okay, then not. Then I'm not using the release flag. If you don't let me, then let's just use source and target. So there are people from Oracle around. This is one of the questions that I would have. Why? As I said, I'm sure there's a good reason. I just don't know it. So now maybe? No. That's the other package that we saw earlier. That's actually from another module. And actually, when you look at it closer, I didn't do that earlier, it actually tells you from which module it is. Package blah is declared in the module Java XML bind. That was the one we looked up. We didn't look up the other one. We looked up this one. OK, more modules to add. So when you use a lot of Java EE APIs, that could be, in this case, that would be unfortunate. So what I did in our application, at first I put in all these command line flags to just make it work somehow, to make the builds work somehow. And then later I worked on removing those flags. So for example, in this case, like very recently, I went through all of our dependencies on Java EE modules and replaced them with third-party implementations. And now it works. No, Maven. Let's see. It's also funny, there's like one test in there, of course it fails. It's like, it's an allegory on actual software development. Hey, it built, woo, we built on Java 9. So now let's run this thing with Java 9. I created symlinks, so I can just call Java 9, and then this is then the, well, you don't have to believe me, I can just show you. So this is my way to run Java 9 applications. See, we still use a class path. We use the exact same command, and then we get this. Wow, we didn't get very far. So at runtime, monitor main exception, blah, blah, class cast exception, some class loader cannot be cast to Java-based Java URL class loader. Well, OK. What's going on there? Let's go into main. What's going on there is, oh, on the right method even, this one. So you know how the system class loader or the application class loader is definitely URL class loader, and you can do things with that? Well, it's not. It has never been specified. When you look at this method, you get back a class loader, which you can't see now, but trust me, you get back a class loader. It was always a URL class loader. That's why you could cast it. And then you could do things like analyze the class path. You could even amend the class path, append the class path and put things on there. In this case, I just look at the URLs because this method getURLs is not available on the regular class loader. And then I turn them to string. And then you remember maybe from way, way, way earlier, I'm probably not going to get there. You remember that there was a large swath of output at the beginning because it, oh, here we go. Because, you know, just for analytical reasons maybe, just to have a look at what's going on, we output the class path content. Because we cast the URL class loader and then we printed the individual URLs. And that's not going to work anymore. So if you rely on the fact that the application class loader is a URL class loader, then you have to find a different way to implement your feature. In this specific case, I think there's a system property that you can ask for the class path, and then you can look at the content yourself. If you're appending jars to the class path, you could instead create a new class loader and delegate to the system class loader. But this no longer works. Instead of finding a proper solution, I just stopped doing it. I just now realized I totally forgot to walk through the slides, but we can do that now. So this should be the last thing, and then it should work. No. Oh yeah, of course it doesn't work. Because the module containing this class, we edit it at compile time, but we have to edit again at runtime. So the module was not available at compile time is as unavailable at runtime, so you have to edit again. You usually have to apply most of the flags that you apply at compile time or at test runtime. Most of these usually also apply at the regular runtime. In this case, many of those don't, because the models that we had to patch, because of the annotations, many of them are just available at compile time and go away at runtime. So that's why we don't have to put in that much effort. Now we just have to add the one module, which is Java XML bind. Oh, you don't have to use an equal sign, by the way. You can just leave a space, but not that way. That way. Finally. There it goes. And the endpoint is still up. Or it's up again. OK, so that was the migration to Java 9. Let's go through all the slides to catch up with what we just did. The runtime images got a new layout. This means that if you have code that looks into the JDK directories to look, what's going on in there, then this will fail because they changed the layout. RTjars, tooljar, these are both gone, which is the reason why the IDE of choice will not work on Java 9 unless it's a Java 9 compatible version. What used to be jars, the tooljars and the RTjars are now JMod files which are unspecified on purpose. You should use runtime APIs to look into these JMod files. The idea is that while jars are just zips, which you cannot really optimize, JMod files can be optimized by the JDK team to improve startup performance, for example. And then, as I said, the application class loader is no longer URL class loader. And you also get a new URL scheme for runtime image content, but all the APIs have been updated. That is only a problem if you cobble these URLs together by yourself. Let's skip that. A couple of things are obsolete. They're no longer compact profiles, the extension mechanism, the endorsed standard override mechanism, and the other things are gone. If you use these, look into alternatives. These are kind of rare. I learned about, I think, well, I knew about compact profiles, but the other 4 I learned about when I learned that they're gone. So they're not that much used. And then there's more. I wrote a migration guide, and I recommend that you take a look at that. I wrote a couple of other posts that are a little bit shorter and not that technical. For example, how to plan your update. That's actually the only non-technical one. How to plan your update. The too long didn't read is don't give anyone numbers how long it takes to update to Java 9. That's like, if you can get around giving someone a number, that would be great. Because you don't know. It could be that everything works smoothly, and then the last thing you find out, for example, that if you cannot cast a URL class loader, then your whole application doesn't work anymore because it's a critical feature. So it could be that something that seems minor could actually break your application. It's not likely, but I would say it's too likely to make any good guesses. My general advice is to look for these 3 things: internal APIs, split packages, and Java EE modules. These are the things you should look at first because these are the most likely problems. And then in general, start getting your code in shape, and I recommend, like what I basically just did now is I built a parallel Java 9 configuration for the build that you can run the same branch on Java 8 and build the same branch on Java 8 and on Java 9 to build continuously the same branch on both versions to make sure that whatever you put into place that works once, you cannot relapse and cannot add in. For example, if you add in a new Java EE dependency, you should know about it to update your build. As I said earlier, check dependencies and tools. And if any of them are suspicious, meaning any of them do something with class loading or with bytecode or with the JDK image content, then you have to update them, and IDEs automatically qualify as to build tools. So get them up to date, and if you're relying on versions or on projects that are not maintained anymore, then you should look into alternatives. And last but not least, just try it. Just download Java 9 and try. Final slide about myself. My name is Nicolai Parlog. I write a blog post. I write a blog post every couple of weeks. But usually I write blog posts on CodeFX.org. I have a YouTube channel, and you can follow me on Twitter. And also I wrote a book about the entire module system thing. I'm still writing the book, but it's almost done. You can get the paper version in June, and you can get the electronic version already for like almost a year now. We're continuously adding chapters. Almost all the content is there. All of the migration stuff is there. And if you're interested to learn more about Java 9, about migration, about the module system, about the other Java 9 features, shoot me a mail to course@codefx.org because we're putting together Java 9 training here in Stockholm, most likely in May. So if you're interested, shoot me a mail. And if you have any questions about anything at all, just find me at the conference or come up now. And for the rest of you, I wish you a great conference.